Hey everybody, happy Monday. All right, got a couple things today. Let's take a peek. Oh, I can kill that music too, unless you like the background vibes. Just turn it like quiet, just a little bit there. Um, we're gonna we bumped out arrays in the array list collection till today. We're gonna go over the solution to project 3, and then we got to finish up our midterm review, right? Because next Wednesday and Monday we've set aside for the midterm. Open book, open notes, open internet, not open neighbor. So starting 10 a.m. on 10/27, it'll open. You don't have to come in if you don't want to. If you want to come in and use the computers here, great. Let me know. Otherwise, I won't plan on showing up. But I'm happy to sit and watch you if you want me to watch you take the test. That's cool, I guess. So we'll do the midterm for that week, and then we'll come back. We'll finish up arrays on 11/3. Talk about file I/O and start our 4th individual project. That's the last individual project. Now, I'm sorry, I did not get all of the project 2s graded. I'll get those in today for sure. My Sunday night was spent helping people with project 3. Way longer than it should have been. But, you know, I love you folks and want it to be successful. But let's not wait until the last minute for project 4, because that was rough. And only 10 submissions. I actually went and looked to see how many people. You have 21 people in the course, and there's only 10 submissions for project 3, so that does not bode well. So let me know what's going on, if there's things we can do to get you caught back up. But then also winter is open for registration now. Hooray! At least for priority registration. If you've got 30 or more credits, if you've got sophomore standing, you can get in with the declared program today, and then tomorrow is, I forget, there's some level here. I think it'll tell us, right, if we look at registration. That's waitlist priority registration. Here we go. Here's the link. Yep. At least 6 credits. You can register tomorrow starting at 7 a.m., and then anybody can register starting Wednesday. So if you've got some credits under your belt, they let you register earlier, get the classes that you need, right, before they let everyone else get in there. So go take a look, see what classes you're interested in. If you're continuing on in the software engineering program, there's a couple courses you're going to need. Specifically, the 2151 course is the next main programming course. So we just pull up some of these here across all campuses. We've got 2. Okay. Oh, jeez. All right, you folks broke it. You broke it. Good job. That. Oh dear. Okay, too many people are registering, I guess. Every so often it locks out. Let's try this again. Search. Okay, maybe it's coming back. Let me try it on my side. Hey, all right, there we go. So 2151. We've got 2 sections. You can take it with me. Tuesday, Thursday mornings. Again, I'm going to try this flex format. I think the experiment's going well so far. Although, at the end of the semester, I'm going to ask which format you chose, because I'm not taking attendance, because I'm bad at that sort of thing. And I'm going to look and see if people who showed up in person did better than people who were remote. And that might help make some choices whether or not I'm going to continue with that format. But I don't know. It's just like an online remote class. You just have to keep up with it, and sometimes that's hard. Or over at Auburn Hills, you can take the course Tuesday night if you're interested in the next programming course here. So that one's in the hopper. C++ is a required course. You can take it online with Mr. Nasser. He's one of our new full-time faculty members. He's awesome. Or in person with Dr. Baugh, who's also awesome. We've got a bunch of awesome people here, of course. Data structures, again, if you can hold off on that until after you take 2151, it's a strong recommendation from myself and Dr. Baugh. Technically, you can do it, and you can make it work, but it will be harder. Just a warning with that. And then 2454, I teach this one Thursday night every semester. This one's my course. I inherited that one. That one's a lot of fun. Web systems development in PHP and Java for web backend stuff. So those are other core courses in the programming track. They're 2818 mobile with Dr. Baugh is online as well. So got some options. We're working on moving more things online, as that seems to be lots of demand in that area. At least what we saw this coming fall. I know you folks are here in person, or at least people I'm talking to here in the room. So I think you might like the in-person format. Sorry that we don't always have both. I think mobile will be in person in the summer. I'd have to look at our schedule and see. So let me know if you got a course you're interested in and want to know when it is, because I've got access to our annual schedule that we used to publish, but I don't think we do anymore. All right, thoughts, questions, concerns? Winter, don't forget, look out when you do register. There's an email from the school that mentions HERF. It's free money, free being it's been paid for through tax dollars. So, no additional cost to you. Grant money that OCC received through the CARES Act, or one of these acts. I don't remember which one it was. Maybe the HERF Act. I don't know. And everybody is eligible regardless of whether or not you get financial aid. If you get financial aid, you get more money. So just all you have to do is ask for it. That was the only requirement. Apparently the fall numbers, many of you students were good at like, hey, why does this email say there's free money, and looked at it suspiciously and didn't ask for it. So they're reminding all of us to tell you, no, this one actually is legit. This HERF money, legit free money. No additional cost money. Don't worry, you'll pay for it in your taxes eventually when you get out into the workforce. But for you now, it's free money upcoming. So do take a look for that. All right, so we've got project 3, we've got the midterm review, and we've got arrays and ArrayLists. I was going to do project 3 first, unless anyone has strong feelings about doing one or the other beforehand. No? Okay, project 3 it is. Let me fire up NetBeans here. I guess I could ask while this loads too, this flex format, there's a group of faculty experimenting with it, not just myself. One of the things they're looking at is getting a better camera system so they can actually use Zoom and do cameras where there'd be one on the class and one on the presenter or teacher up front, and then you could display everyone who's online on a screen as well to make it feel more like you're both in person sort of thing, remote, for remote synchronous options. I don't know if that would be interesting at all for you folks, but I mean, my Twitch obviously doesn't do any video cameras from anybody else or even voice at all for anybody else. I thought that was a fine format, but if the like live interaction Zoom thing would be more attractive, I definitely would look into that for you folks, and hopefully they're going to be equipping a couple of the rooms across all the campuses for stuff like that as we try and get more faculty into this remote live thing. I don't think everyone's going to be open to the asynchronous option, but at least in person versus remote live via Zoom, we've got good technology in the works to do a mix of that. So I thought that was kind of interesting coming up as well. All right, so Java program, Java with Ant. Let's put this project 3. No, oh, did we do a project 3 shell? No, I did. This was for the evening class. We'll do this for the morning. That's why. All right. And I want to show you, there's an approach to writing unit tests, which is somewhat popular. I think it's gaining a strong following, called test-driven development. And this idea that if we know what code we're supposed to write, what this class is supposed to do, if you know that well enough, because we've spent some time thinking about it, we kind of might maybe use it in some of those UML diagrams to look at here's what the class looks like, and here's its behavior. You can write your unit tests first to say, okay, this is what should happen when my code is done. And then all the tests will fail, which seems like a bad thing, but that's a good thing. You want all the tests to fail, and then you can focus on writing the code to make your tests pass, to add the functionality that's required. So a couple benefits of that: it keeps you nice and focused on, okay, here's essentially a checklist of, okay, do this one, 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 and you work your way through it. You haven't yet, but hopefully we'll get to the point when we do our final project that you'll find, hey, we could do more interesting things with our programs, right? Our little vehicle class was only, it's small, wasn't a whole lot to it, but there's this idea of creep or scope creep, that you start adding more functionality than you really need to, right? So having your tests done first, you're writing just the tests that you need, and then you'll write the code to make the failing tests pass. It's kind of satisfying to go from this pass-fail, or from failing to passing, which is kind of fun. All right, so I'm going to come to the Project 3 morning package. I'm going to right-click and add a new Java class. We'll call it vehicle. Now, to do that, you should type it and spell it the right way first. Let me refactor rename, because that will rename the file as well. So I get for typing too fast. Vehicle, there we go. All right, so I need all the methods to exist, but the methods don't need to do the right thing yet, is the idea with this. So I'm going to need the constructor, I'm going to need my get methods, I'm going to need my set color method, I'm going to need my drive and add gas methods. So we've looked at, these are all the methods we're going to need here. So I'm going to write them out, but they're not going to do anything yet. To have the methods, right, let the tool do some of this work for me, we need to define all of our variables. So I'm going to have a private string for make, private string for model. So I do have some code here. We're just not going to have everything complete. A string for color, private double for the gas tank capacity in liters, private double for gas currently in the tank, or in tank, I don't know, in liters, right? And then a double for, oops, private double. This was kilometers per liter average. Sure. Right, I think those are the ones we needed. Okay, and again, names, if you're a little bit different than me, that's okay. You know, anything that makes sense and is explicit. And if you're doing something that's measured in a particular unit, like liters, it's important to name the variable with the unit. Because if I just say gas tank capacity, most of you are going to assume gallons because we use our terrible imperial system, and its gallons are like the worst unit of measure ever. Right? Who puts 16 cups in a gallon? Like, why does that make any sense? Or why are there 4 tablespoons in a quarter cup, but 3 teaspoons in a single tablespoon? The way we measure stuff is just ridiculous. So anyway, if we got our units, we got our attributes here. Now we're going to right-click and insert code. We're going to let the tool do the work for us. So we need getters for everything, so people can get access to our private variables. Right? We can tell them what our current value is. We're just going to check them all and generate. Okay, and then we said for setting things, it doesn't really make sense to set the make and set the model. Right? Once you make a car that is a Chevy Bolt, it will always be a Chevy Bolt. Right? It was never not one of those things. Your gas tank capacity, I guess technically you could change that if you really tried hard. We're just going to assume people don't do that because that's crazy, right? Who changes their gas tank? And then the kilometers per liter average, I know this one does change, but we're just going to go like, here's the EPA estimate and forget it. And just to make our life easy. The gas currently in tank does change, but again, like our bank account example, you don't walk up to the bank and say, hey, please set my balance to $10,000. Right? You interact with it by adding money or taking out money. So we're going to interact with our gas in the tank by driving, which will use the gas, and by adding gas, which will increase the amount of gas. So we don't need sets on anything except for color, because you can go paint a car, right? So depending on your class, you'll have different sets based on what makes sense to change, right? That's the idea. The class is taking care of itself. And we're taking all the details, encapsulating them up into a nice little package here, giving you that abstract public interface that you can work with abstractly with this abstraction idea. Okay, so I got a set color, I got all my gets. Then we need a constructor. So I'm going to insert code, go to constructor. I want everything except gas currently in the tank. I talked with a couple people who had that. There's nothing wrong with that, but you know, usually when you make a brand new car, the tank's empty. Right? You might put some gas in the tank to test it after it's all put together, but usually you don't put gas in the tank when it rolls off the floor. Right? That's a step after the fact. So I'm going to not include that one. And what we're going to do then is we're just going to set it to 0. We'll say, okay, when you make a new vehicle, it has no gas in the tank. If you took an argument for it, that's fine. No big deal there. Right? And we're just kind of going along. Let me go edit this. Ooh, and I do have, I forgot though to add it now. There's a little gift shop nearby my house. They opened in, like in the middle of the pandemic, opened a tiny little boutique gift shop in a small little city downtown. I don't understand it, and I really hope they don't go out of business, but you know, they're sweet people. But they had a pack of knock-knock jokes that I bought. So I'm going to add a channel point reward for tell a knock knock joke instead of just a dad joke. And now I've got a whole 100 of them. So we probably won't hit any repeats. But yeah, anyway, so we're kind of going along the rubric here. So we've got our vehicle class has private attributes, right? That's our goal. We don't want public attributes. We want private attributes with public get methods. Is that too hard to see? Sorry. We have get methods for all the attributes. We have a set color method, right? Then we're going to need add gas and drive. So we're getting there. So this constructor didn't explicitly mention you needed the constructor here, but if all the attributes are private and you don't have sets for the other things, the only way to give them a value is through the constructor, right? When you make this instance a vehicle, you tell it, hey, you're a Chevy Volt, right? Your color is gray. This is your gas tank capacity. This is your miles per kilometers per average, and you have no gas in the tank. Great, right? Those will never change now. Here, you can go change the color, yes, but there's no set make, there's no set model. So the constructor's job is to set values to all of our attributes, and some of them never change. Right? In some classes, all of them can change. It just depends. So kind of depends on the class there. So we got our constructor, we got our sets, we got our gets, and we're going to do the public. Now the add gas and drive were Boolean type methods because we're going to tell them true it worked or false something went wrong. There's better ways to do it. We'll get to that later when we talk more about exceptions. But for now, we can indicate success with true, failure with false. So we'll have add gas. That takes a double, I don't know, gas in liters to add or something. Right? How much gas are we going to add? Again, specifying the unit is helpful because we're telling them, hey, this is how many liters we're adding here. This will show up later, right? The name of your argument or parameter here is going to show up when they start typing. And if you don't get that type ahead stuff, go up to Tools, Options, go to the Editor tab, click on the Code Completion tab, click on Languages, pick Java. You want to make sure this second and third box is checked. If you don't have the type ahead, checking those will give you all that type ahead, that IntelliSense sort of thing. So as you start typing something, it'll suggest variable names for you. That's huge. I thought I covered that before, but if not, I apologize. That's your tip for like, if you start typing something, it suggests, hey, do you want one of these things? Okay. All right, so add gas. So for now, I'm just going to say return false because I'm not going to write all of the logic in here yet. I want the method to exist so I can write tests for it. But for now, it's just going to be false all the time. And same with drive. So public Boolean drive, given a double kilometers to drive, we're just going to return a false. Right? We'll come back and finish these later. I want them to exist so I can go write my tests, then we'll come back to them. So to get to the tests, you right-click your vehicle class, you go to Navigate, go to Test, make sure you pick on JUnit 4 here. No other boxes other than these first three are checked, or say OK. It should generate everything we need for us. Awesome. So we got this test file, does all the imports here. We don't do anything in this constructor. There's really cool things you can do with testing later on, that's, again, beyond us. So now we can start writing test methods. So the idea here with our tests is that we needed 100% code coverage so that every scenario, right, every if and else block is going to be run when our tests run. That's the idea with code coverage. So all of the gets are going to get covered when we do the constructor, right? We also know if we, not really cheat, but if instead of calling this color equals color, if we just say set color, given the color, and we use our method, now our set is also covered and will run when the constructor runs. And generally, if you have a set method, you're better off calling it in the constructor because you may or may not have some sort of validation. For color, we can't validate because there's like a bazillion different colors and everyone comes up with new, like a new word for a color nowadays. You know, it's not just our boring rainbow colors. We get, I don't know, I can't even think of any silly ones now, but all sorts of fun colors. So we're not validating. We didn't really gain much here except for I know this code now will run when my constructor is called. So in terms of testing, I'm not going to need a separate test just for set color. Right, so then what I'm going to need different tests for is for add gas, if we get a true or a false result. For drive, we get a true or a false result. So I know I need at least 2 tests for drive and 2 tests for gas, add gas, right? One that returns a true, one that returns a false, because I want to make sure I get that 100% code coverage. So I'm going to write a at test, public void, we'll write a test constructor first. So we're going to do 3 things, right? We're going to arrange, then we're going to act, and we're going to assert. So to arrange, what are all the things we expect? We're going to have an expected make, an expected model, expected color, expected this, expected that, all of our attributes, right? All 6 of them here. So we're going to have a string for expected make, equals Chevy, a string for the expected model. Let's call this one a volt, a string for the expected color, make it gray. Now, do you spell gray with an E or an A? Apparently, they're both correct. I usually use the E, but apparently A is correct as well. I don't know. English is weird. A double for expected gas tank capacity. Gas tank capacity in liters. I don't know, let's say 10 liters? I don't actually know. And the number really doesn't matter, right? As long as we're getting the same number, we know what we're giving it, we know what we can expect back out. We'll have an expected gas in tank in liters, should be 0, right? And then a double expected kilometers per liter average. We'll say, I don't know, 10. Again, the number really doesn't matter. If I give it a number, do I get it back out? So I'm going to act. So act is the code that we're testing. So if we're testing the constructor, I need to call the constructor my act section. So we'll say vehicle, vehicle equals vehicle, I can't spell, equals a new vehicle. Given, it needs the make, the model, expected make, model, color, and then I'm going to come down a line just to make this a little easier to see. Our gas tank capacity. Oh, I missed my comma there. That's why it's not working. Capacity, and then the kilometers per liter average. Okay, so now I called the code I'm testing. Now I need to get the values, ask the class, okay, what values do you think you have? So I'll have a string for the actual make equals my vehicle dot get make. A string for the actual model. So it's a little tedious to do this, but again, this is all the things we would have been doing. Oops, vehicle dot in a main method here, but I don't need to make a main method and actually eyeball what I print out to the screen, right? The idea is I can make the computer do this test because it's not going to screw it up. Just like when you write, oh no, expected, no, actual color, sorry, actual color. I can't talk and type at the same time, so I'm not saying what I'm typing. Get color, and then a double for the actual gas tank capacity. I'll just copy paste these here. Oh, sorry, that was double actual. Grab that actual word here, actual word here. Nope, not expected. There we go. And then those are all my vehicle dots. Vehicle dot get capacity. Vehicle dot get gas currently in the tank in liters, and vehicle dot kilometers, get kilometers per liter average. There we go. All right, now I get all my actual values. Now I can assert. Now I'll say, hey, Java, you go check. These should be equal. Right? This is the assert step. So we'll assert equal equals, given the expected make and the actual make. Right? You give it the expected first and the actual second. Boom, boom, boom. 6 of these, right? For model and model, for color and color, gas tank capacity, gas tank capacity, gas and tank in liters, kilometers per average. Great. And we'll go back to our expecteds. Expected model, expected color, gas and tank, gas capacity, gas and tank, kilometers per liter average. Now, if you are comparing doubles, remember, Java's bad at arithmetic, so we need to give it that delta value. How close is close enough? So all these I need to say like 0.0001 or something. Some amount of distance between the two that we'll say is close enough to be equal here. Okay, so I've got my test for constructor. I make the vehicle, and then I get all the attributes back out. If I give it these attributes, here's what I expect, including the one that I'm defaulting to 0. Like, what is my default value? I want to check to see what's the default value of these attributes. All right, and we'll give that a test to run. This one will actually pass because we like have that shell of a constructor. Yeah.
Your color is well.
My color. Oh, yep. So that will fail. You can't compare a double and a color. Let's copy paste. There we go. Thank you. I think the other ones are good then. Yep. So yeah, expected 10 was gray. So run again. All right. Now that one passes. Awesome. So that one passes. So the constructor, again, not a whole lot was going on there, so not too concerned if that one passes. They're ideally want them to fail so that you know you have to do something else to make them pass, but this is fine because it generates that code for us. No big deal. So we're going to write another test for void. This is add gas, I don't know, returns true. Here. Oh, again, we don't need most of these things now. The things I care about are going to be the capacity is going to matter, and the gas in the tank, I'm going to expect a certain amount. Right, so the make, model, color, we don't need most of those things. So when I copy paste most of this here, we can trim most of that out. Right, so I don't need any of the colors. Really, I can keep the capacity, that's fine. And then I can say, okay, let me expect to put in like 5 liters maybe. And I don't need the double there. So I can just give it anything that's a string. It doesn't care what the string is. So I'm just going to give it an empty string here. And, you know, sure, the number value doesn't matter here. It could be 0, but zeros are a little funny sometimes when you give them the numbers. So I don't need the actuals. I don't need the actual capacity. All I need is this one here. And technically, this is the arrange step now at this point, right? We're setting up the instance. That's not the code we're testing. So only the code we're testing goes in here. So I'll call vehicle.addGas, and I'll give it my expected gas in tank in liters. Right? If I go add 5 liters, I should get back out 5 liters. So these ones can go away, that one can go away, this last one can go away. But then I also need to store the result of add gas, because add gas is going to return a value. So I'll say, hey, this is a Boolean. I like to call it result. You can call it anything you want. Then I can assert that this one should be true. Right? I should be able to add 5 liters to a 10-liter tank. So instead of assert equals true, I can just say assert true as a little shortcut, given the result. Like if you want to do assert equals, you can do your result and the word true, perfectly fine, but you've done more typing than you need to. Now, this one's going to fail because I know our add gas method never returns true, and we're not going to actually have 5 liters in the tank because our method doesn't do anything yet. So this is good when we test this one and it fails. Right? Okay, good. And you can open it up and you can see, where is it in here? It failed, returns true. So that line 59 is what failed, or assert true failed. Sure. Okay, now we're going to write a second test, copy paste this one, for should return false. Returns false. So to make it return false, we need to put more liters in the tank, right, than we should have. So I need to put more in than my capacity. That's the idea that you overflow your tank. Your tank still has the capacity, right? You can keep on pouring over and over and over, but you're never going to get more than 10 liters in that tank. So if my expected gas in the tank should be 10, right, given my capacity of 10, when I add gas then, I want to have more than that. So I'm just going to do like times 2. In a couple different ways of doing this. You could add another variable, you could do all sorts of things, but I like doubling the amount that I expect. I know we'll overfill it. And then this should be false then. And when I'm done, I should have 10 liters in a 10-liter tank. We filled it up, but it told me false, you spilled gas all over the place, you're a dummy. That sort of thing. A little format. And this one, this part will pass, but this part will fail because we're not actually adding gas yet, right? Because we're always returning false. So the return false will pass for now. We're going to feel a little bit bad about it, but that's okay. Let's see. Yep, and that one failed. So expected at 10 was 0. You thought you'd have 10 liters in the tank. We actually got back 0. Okay, good so far. We're going to do the same thing with drive now. We need a returns true and a returns false. So I'll copy this one. So returns, this is drive, returns true. Now to drive, you need gas in the tank. So we need to add gas to the tank before we can drive. Right? Then we can actually go and drive, vehicle.drive. And if we go 5 kilometers per liter, right? This is the arithmetic we need to know, is how much gas will be left in the tank after here. So I might want another variable for that. So this is my expected kilometers per liter average. I will just set it at 5. 5 should be fine here. And I'll use that here, because that way I can have some arithmetic. So if I put 5 gallons in, and I drive 5 kilometers, that means I should use 1 liter, right? So I'm expecting then to have 4 if I add, I don't know, double amount of gas to add or something. To add is 5. If I add 5 here, and then I drive, I should get 4 left when I'm done. And I like more variables. If you just put the number right into the method here, I'm not too concerned. Generally, we'd like to put names to things, though. Right? That the same sort of rule of thumb. When you're using hard-coded numbers, they should be associated with a variable name, so you know why you have this weird hard-coded number. It's a little bit overkill in the tests, but that's okay. Right? No big deal here. So we'll call drive. We want to drive how many kilometers? We'll make a double kilometers. The drive is 5 kilometers. Sure. You can drive 5 kilometers. After we drive 5 kilometers, we should get a true result because we had enough gas for that. The amount of gas that should be left should equal 4. Right? We could even do the arithmetic then if we wanted. Right? The expected gas in tank could be, right, let me format that. Could be the amount of gas to add, right, minus the kilometers to drive divided by the kilometers per liter average. I'm going to move that one up. Right, we could do the same arithmetic if we really wanted to. Right? I know, or we could just put the number 4 in. Right? Either way, I'm not too concerned. We've got the same formula we're going to use. Sure, or you could just hard code in the number. Either one is fine. Not too concerned. But this should fail. Or I'm sorry, this should be true. We had enough to drive. We'll do one more here, where it should return a false. So if I add 1 liter of gas, and I want to drive 10 kilometers, now this formula is no good here. I just know we're going to end up with no gas. We're going to use all the gas here. Return false. So if I put in 1 liter of gas and I drive 10 kilometers, it's going to tell me, nope, I didn't have enough gas to drive that because I can only get 5 kilometers per liter. Right? So then we should go to false result, and we should have no gas left in the tank when we're done because we used all the gas. That make sense? Trying to clean that up a little bit. So those ones should fail. Actually, this one might pass because we always get a false result and there's never gas in the tank. That one might pass. I'm going to feel a little bit bad about that, but that's okay. We've got the test for it. Yeah, returns false. Sure. Okay, so now I have all the tests. Right? Oh my goodness, I just lost it. There it is. Now my goal is to make the tests pass. So I wrote my tests first because I know what the code is supposed to do. Now I can go back and actually write the code here in vehicle to do these things the right way. So let's do add gas first because you can't drive until you have gas. Right? So I think this will make sense to add first. So we're going to take our gas in liters to add. We're going to add it to the gas currently in the tank. Right? You want to add some gas? Sure, we'll add the gas in liters to add. Boom, done. We've added the gas. Now we need to see, did you do a bad thing and overfill the tank? Right? The class code, its job is to make sure it has integrity and make sure you can't put it in a bad state with these public methods. So if you say add 1,000 liters, I can't actually have 1,000 liters in my tank. Right? I mean, I guess you could have a 1,000-liter tank, but then you're driving probably a literal tank at some point. I don't actually know how much gas those things hold. How much gas do you think a tank holds? That's probably not the word tank. No. Military tank? 5,000 gallons. Wow, that's more than 10,000 liters, right? Because it's about 4 liters per gallon. Oh no, that's like a portable supply of fuel.
Mm-hmm.
Okay. The M1 Abrams tank could hold 500. Oh, geez, 500 gallons. That's more than almost 2,000 liters, right? That's a lot of gas in that thing. All right. Anyway, sorry, we got off track there. So we add it to them, and then we need to see, hey, did we overfill? Right. So if the gas currently in my tank is greater than my capacity, then we did a bad thing. We need to fix it, right? So let's set that to the capacity. Say, okay, you put in way too much. Let's just pretend like we stopped at the capacity. Pretend like we didn't ever go above. As far as anyone cares, they don't know that for like a split second, we're over our capacity here. Because before the method's done, we're fixing that. right? And then I'm going to return a false. A bad thing happened. I fixed it, but you did a bad thing. If we didn't return a false, then I can return true. It worked. Again, an else at this point is redundant, because if this code didn't run, this will run. If it did run, then you're returning and the method stops anyway. So nothing wrong with an else, it's just extra redundant typing that we don't need. So let's add gas. We can come back to our tests, we can run our tests again. And our add gas test should pass if we did right. Oh, let's see. Add gas returns true? Oh dear, we screwed up. We screwed it up somewhere. What went wrong? I don't think it actually compiled the code here. I think that's my setting here. I hate this setting. Hate it. File on save. That's the worst. All right, now we run it again. Just thinking about it. There, now our add gas worked. Okay, so if we actually get the code we wrote and that gets compiled, life is good. So now we still need drive. Drive returns false, returns true. They both fail. Okay. Oh, interesting. This one used to pass, right? But now the add gas actually works. We're not actually using the gas. So it says, hey, we expected a 0, but we actually had 1 liter in the tank because drive didn't use up the gas. So like we made it fail by making add gas work, which is kind of funny. We'll come back now, we'll fix our drive method. So drive, okay? So a couple ways of doing it, right? We can calculate the value first and then see if it's greater than or less than, or we can just calculate the value. So we'll just say double is the liters required to drive is going to be my kilometers to drive divided by my kilometers per liter average. Right? You want to drive 10 kilometers and I get 5 kilometers per liter, you need 2 liters. Then I'll take my gas currently in the tank and subtract those. Gas currently in the tank minus the liters required to drive. And then, hey, if we went negative, if I used up more than I had, right? If the gas now is less than 0, we did a bad thing. Let's fix that. Put it to 0 and return false. You ran out of gas, dummy. Which has happened to me. It's the worst thing. I took my newborn daughter, like the first time I went out with her for fun, I went to like a little library program, and the car needed gas, and I was like, okay, I'll stop on the way, but we were running late, so I was like, okay, I'll stop on the way home. And I got on the freeway and got off the wrong exit or on-ramp or something, because I just wasn't paying enough attention, and ran out of gas. So I didn't make it to the gas station. So wife had to come bring gas. That was fun. I think that's the only time I've actually run out of gas in the tank, though. Otherwise, we can return true, it works. Right? If you didn't run out, then yeah, you were successful. All right, let's give those a run. And our test pass. Okay, so I think then we're done. We have add gas, we have drive, we have a unit test. We're 100% code coverage. We're testing both scenarios so that all the blocks of code will run. Right, this block will run and this will run. This block will run and this block will run. That's it. That's vehicle. How'd you folks do? Did it feel okay? Cool. I think it might have been a little bit of a mixed bag, especially given we only had 10 submissions. Nope, I didn't make any changes. No thanks. Don't save anything. Yeah, that's unfortunate. All right, so we have arrays and array lists, and then we have the midterm review to work on. Or we can take a break. I've been talking for a little while. Which one do you want to do first? You're going to do like midterm review and then take a break and then do arrays? Okay. You folks never care. I'm sorry. All right, so let's do midterm review. Midterm review for the morning. Hold the midterm review. Again, the quiz style questions, they'll be similar to what you've been doing for the quiz style questions. Nope, that's not it. Midterm over here. Come back. Go back. Go back. So I wasn't going to bother with the quiz questions, or the short style questions, because they'll be different. They'll be what you're seeing. But you get 1 free point just for acknowledging the academic integrity policy for the course. Right? Open book, open notes, open internet. You cannot work with another person on it. You cannot post things on Chegg. Right? All of that should be obvious, and it's not. It makes me sad. So you get 1 point for acknowledging that. And then a bunch of quiz questions, quiz style questions, and then some long answers. Like write a loop. Again, don't forget, or don't worry about the file portion of this. Again, the previous book did stuff in a little bit a different order here. So we're going to write a list, enter the list of classes they need to take, and write them 1 class per line to a file. So if it doesn't mention how many, right, we have options. You could ask them how many classes do you need to take, and then do a for loop, or we could do a while loop and ask them, do you have more classes to enter, yes or no, and keep on going off of that. Or we could use a sentinel value and say, keep entering classes or the word all done to stop your loop. Right? Any 3 of those are perfectly valid. They will still get the list of classes that you need. I'm partial to the sentinel value because then they don't need to keep typing yes, 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 yes after every answer. So I'm fond of that one. So that's the way I'll do it here. So we need to get their inputs. We need a scanner then, right? Keyboard equals new scanner. Given system.in, system.in, and then we'll print. Enter the name of a class you need to take, or all done to stop. Right? And we're going to do this while, here's our class, oh my goodness. String for class name, equals keyboard.next line, and while class name equals ignore case, all done, and as long as it's not that, right, we can keep on asking them. And really, if you want to save some typing, you can do these 2 things inside the loop, as long as we declare class name here as something that is not all done, and then we can just reassign class name each time. We got to add our import here. Right, start it with something to make the loop run once, or you could do a do loop. Again, I hate do loops, so I don't use them if I can help it. So we'll say, okay, as long as it's not all done, hey, enter the name, get it, and let's go. Get the name, do it, and let's go. So if you were to do something else with that, like add it to a list or to a file or something, we need another step, but we're just not there yet, and that's okay. So we just keep on asking them until they're all done. That's it for that question. Right, 5 points. Just a little loop. Again, a for loop would be fine if you ask how many, or do you have more to enter, and we're looping off of yes, do you have more, yes or no. Either way is perfectly fine. Right? Those will all get the job done of asking them to do this. Okay, so some question on loops. Write a method. Plus, minus, multiply requires 4 integer arguments. Add the first 2, subtract the third, multiply the fourth, return the result of that. So plus, minus, multiply. So we'll write a method for that. So public static void plus, if it returns the result, right, it probably returns an integer, not a void method, sorry. Plus, minus, multiply. Takes an int first, int second, int third, int fourth. Now, you have to be a little careful here, because order of operations matters. If you add the first, subtract the third, and then multiply by the fourth, right, it's not multiplying the third and fourth, subtracting that from the first plus the second. Right, so you can't do it in a single return, first plus second minus third times fourth. If you don't have parentheses here, you've done the wrong thing. Okay, order of operations matter. So if you do want to do it in one line, perfectly fine. Do this first, then multiply by the fourth. We're good, right? Or do it in a bunch of different steps, right? Either way, or you can have like an int result equals first plus second. First. Goodness, not bad. I don't even know what that is. First plus second, result minus the third, result times equals the fourth. Return result. Right? Either way is perfectly fine. No big deal. As long as we're getting the right order of operations, we don't care. Java doesn't care. You can do the arithmetic any way you want. Here, either way is okay. Does that make sense? Right, that's the next one. So something similar, you'll do some sort of arithmetic operations with a method here. Okay, I'll probably throw in an if or an else for fun, because this one's a little short here. Again, the goal was you could do it in 2 hours. So like it was meant to not be stressful, but even then people have exam stress, and I understand that and I hate it. So I'll do what I can. All right, last one, our class for flower. Private attributes for name, color, smell, number of petals. Add a get method for the attributes. Add a method pick a petal, which reduces the number of petals the flower has, but does not allow it to go below 0. So we need to add a class. We're going to add, oops, in the midterm review, let's add it in the right location here. Let's add a class for flower. It has strings for name, color, smell, right? Name, color, smell, number of petals. So private string for name, private string for color, private string for smell, and a private int number of petals. Okay, we need get methods for all of them, so let's let the tool do the work for us, right? Here's our code, getter, and when you're taking the exam, please use NetBeans, right? Actually do your code and run it. Right, so generate the gets. Right, if you want to have sets, that's fine. I didn't ask for them, or if you want to have a constructor, that's fine. Again, I didn't ask for either one, so either route would have been fine. But you do need a way to set the values. If you don't include sets, right, you're never giving these values, and you're not going to get the points for it. Right, so that's kind of implicit in that to give these values, you have to have the constructor or set methods. It was up to you to pick one or the other. Okay, again. You know, the name of a flower probably never changes. The color of a flower, yeah, that could change, I guess, depending, maybe. Like throughout the season, maybe it changes. I don't know. The smell of a flower probably doesn't change. So I'm going to go with the constructor and not do sets. But either way would be fine. And I just want everything, right? You give me all of that here. Great. And I'll set the values. Then I need that pick a petal. So public void pick a petal. Right, pick a petal should reduce the number of petals, but make sure it's not negative. Right, reduce the number of petals the flower has. Do not let it go below 0. So 2 options: one, we reduce it and then check to see if we went below 0 and fix it, or one, we only reduce it if we're positive. Right, so we can say, hey, if number of petals is greater than 0, number of petals minus minus. I think that's probably the simplest. So if we have petals left, pick one. Right? Or you could go the other route, take it away, and then check to see like we did with the vehicle. Both will do the exact same thing, right? They'll both accomplish the goal. Okay, that was it for that. That was it for that one. And again, you could just copy paste this flower class into the text box, right? You just for the method, copy paste the method in. You can give it all there, so you should have plenty of room to take it. Okay, questions, thoughts, concerns about the midterm? And the goal is low stress. Low stress. I hate stressful exams. So cool. All right, why don't we take a quick little break before we talk about arrays and array lists. We'll pick up that new stuff, which is not on the exam, unfortunately. I hope you don't mind that. And it's a little weird to do new stuff that's not on the test, but we were just running a little short on time. I didn't want to push it out because our project needs to cover arrays, array lists, and file input and output. So, and we got to do project 4 before we get to the Java FX stuff. I don't think we have time. Yeah, because we got to do this before Thanksgiving break. Otherwise, we're short on time for the final project. So, yeah. So we'll talk about arrays and array lists. If we don't finish all of it, and that's okay if we don't, we'll pick it up after the midterm. I think we'll be in good enough shape after that. Okay? All right, so why don't we take 10, and then we'll come back and do our arrays and array lists, and we can go from there. Break time. We'll come back at, what does that put us at? 11:08. Cool. See you in a minute. Alrighty, we're back to new stuff now. Let me start up a new project here. Call this arrays and array lists. Oops, for the morning. That's what I named it last time. We might not get to array lists, but that's okay. We'll cover arrays. Array lists are actually easier than arrays, so we can get to those. Show you all the nice stuff after. Save all there. And close that. Oh, I didn't commit those to GitHub. Let me commit those to GitHub so that's out there for you too. And I can turn that down. Here we go. 300. Ooh, look at that, all those files. 3. Review. I'll wait on these ones. So you can be selective about what you commit if you want to. I'll just leave it for the next one. There. So the next time we commit, we can save all those ones. Oh, I gotta push. And push. All right, so the idea with an array so far has been every variable can hold one value. And we can write a class that can have a bunch of attributes, so technically our one variable could have a whole bunch of other attributes, but we're still doing things one at a time. Right? Here's the name for it, here's the name for it, here's the name for it, here's the name for it. And if I were to say, hey, enter 10 numbers, and I want to keep track of all 10 numbers that you enter, right? We have to say int number 1, int number 2, int number 3, int number 4, int number 5, on and on and on and on. And that's really tedious, right, to store all of those. So what we can do instead, we can say, hey, I want an integer array. So an array is a bunch of values. We use square brace notation here, say numbers. Now there's a couple ways of doing these. So in int array, we're going to call numbers here, equals new int array, and then you have to tell it the size. So on the right-hand side, when you instantiate it, you have to tell it how many values it's going to hold. This is our array notation. So we use square braces, the name for the variable, then equals new. So we're using that new keyword, just like when we used classes, right? It creates a new instance. This is instantiating this array here in memory. So we have 10 places to hold integers. Now what's really cool behind the scenes here, let me open up a Word real quick, and I can draw on this, is that it goes out and Java asks the operating system for a contiguous block of memory. So all of these values are going to be next to each other in memory here. So like when we told Java we wanted an int, and we just said, here's my number. Java would say, okay, sure, here's x3 to fb. You can go store, is it 4 bytes? Right, for an integer? Right, I think we do 4 bytes. And it would give you this block and 4 bytes worth of memory. Great, that one's yours reserved. When you say you want numbers, right, an int array here with the square braces equals new int array size 10, it says, oh, okay, I know an int is 4 bytes. You need 10 of those together. You need 40 bytes of memory. Sure, let's go out here, x4 to a 0, and I'll give you 40 bytes of memory out here, and you can store 10 ints. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The first integer we store is at 42A0. That's the first integer. The next integer we store is 4 bytes later. Right, so that's 42A4. It's here. 4 bytes later. 42A8. That's a 4. Right, it's that one here. Right, add 4 more bytes, 4 more bytes, right? So each one is just 4 bytes later, on and on and on, plus 4 bytes. Plus 4, plus 4, plus 4, on and on and on. So because you get a contiguous block of memory, they're all next to each other in one spot here in memory. What that means then is you access them really quickly using this arrays, this variable for it. Sorry, I forgot to get chat here. Use that notation to access it. The first item is at that address here. So if you wanted to calculate, hey, what's the address of the 7th number here? Well, arrays are funny, and you're going to hate it for a little while, but you get used to it. The first index, so we say, hey, these all have an index here, right, that you reference them. Hey, the first thing, the second thing, the third thing, we say it's the index here. The first one is index 0. and then it's index 1, 2, 3, all the way down to 9. So you never get an index of your size. You're from 0 up to, but not including your size, because we start at 0. Right? Chat's still not loading for me on my phone. Okay, no chat. So what it does, if you want index 7, I'm sorry, if you want the 7th item, that is at index 6. Right? Because we start at 0. So the first item is index 0, the 7th item is index 6, the 10th item is index 9, on and on and on. It says, okay, 42A0 plus the size of an int times the index is the arithmetic it does. So if you want the 7th item, you give it index 6, it takes that memory address and adds 24 bytes to it. And it says, oh, okay, you want the one right over here. It can do that arithmetic instantly. Right? It's really quick. So you get immediate access to any value in that array because it does all this arithmetic. So at index 0, right, the size of an integer times 0 means the first value is right here at the memory address. Okay, so that's why we're 0 based here. So our first index is at 0. So now I can give it values. I can say, hey, numbers. And then I use these square braces again. I'd say at index of 0 is equal to, I don't know, like we'll put in 10. Numbers at index of 1 is 20. Numbers at index of 2 is 25. I don't know, and we just keep on going, right? Numbers on and on and on and on. So that's how we can assign values. You can also then say, hey, numbers index of 3 is equal to, you can get values back out with the same notation. Let's do numbers index of, let's do this one. Let's change, I like this. We'll do 1 and 1, and then we'll say 2 is the numbers index of 0 plus numbers index of 1. They give me the value of the first thing at index 0, the second thing at index 1. And then we'll go on and on and on. We'll keep following this pattern. And if you remember back to math class, this is a particular pattern here. Index of 2, called the Fibonacci sequence. It's found in nature often, where each number is the sum of the previous two. So you can set or get using this index notation, which is really cool. So you can get the values out or set the values. This is a little tedious if we were going to ask the user for a bunch of values, right? If we wanted to say, hey, enter the first value, enter the second value or something. So let's use a scanner keyboard. So new scanner, given system.in. So oftentimes when we have an array and we need to ask the user for values or something like that, so we'll put I don't know, an int array for users numbers equals a new int array. We'll just say like size 5. I'm going to do a for loop. I'll say for int index is 0, because we're going to start off at 0. Index is less than. Now arrays know how long they are. So if you say the array.length will give you the number of items in the array. So an array of size 5 is length of 5. So if my loop says as long as I'm less than that, and if I go from 0 up to, but not including the length, I'm going to get index 0, index 1, index 2, index 3, and index 4. I'm going to get all 5 indexes in this loop. Oops. Index plus plus. Right? We can say, okay, enter the value for index, and then just throw the index in here. And then we can say my user's numbers at index, right? Index of my index value here, right? Equals the integer.parseInt of the keyboard.next line. Okay, and then we'll keep on going. So enter the first value, enter the second value, right? Index 0, index 1, index 2, index 3, index 4, and we can enter all the values. Now, it doesn't print nicely, though. If you were to say, hey, print the user's numbers, it's going to look like garbage, and that's okay. Don't worry too much about that. Compile and save. You're killing me here. All right, still didn't connect to chat. What's wrong with my Twitch app? Now we'll give it a run. There we go. So what value should we enter? It really doesn't matter. We'll just do 1, 2, 3, 4, and 5. When you print it out, you get garbage. This is an integer array at memory address 6D03E736. That's not helpful for us. So printing out an array is more difficult than just printing the array variable. You have to loop through every item and print it, right? So to loop through every item, we can say for Now, there's a shorthand notation for doing this. Turns out you loop through every item often enough that doing this index thing is tedious. So we can say for int number colon numbers. And that might look familiar to when we did our hangman, right? We took a character array and looped through one character at a time. This is shorthand notation for taking a collection of items and looping through one value at a time. So the individual integer, so it takes one at a time, assigns it to number. So one value at a time we've assigned to number here to then go through and we can print out the number. Okay. Now it's worth noting here that this is read-only. If you go and change number, you're not going to change the value inside the array because this is a read-only loop. If you want to change the values, you have to do it by index, right? But index, you can assign values here by index. With the read-only loop, you can't because it's read-only. But now we should be able to get our numbers back out, right? So if we enter a bunch of numbers, 1, 2, 3, 4, 5, we get out. Oh, I did the wrong array here. That was me. Oh my goodness, NetBeans. I did the numbers array, which had a couple numbers here, not the user's numbers. How about that? If we do the right one here, we should get our numbers back out. So always worth testing your code. That was totally on purpose, right? 1, 2, 3, 4, 5. We get 1, 2, 3, 4, 5 back out. Yeah, not exciting, but we can get our values out here, right? Let's see. Let's go back here. So let's do the same thing with our Fibonacci loop here for just a second. But now I need the first two to be assigned because I can't get a previous value from an index that doesn't exist here. So we'll just go back and we'll finish this out. So we'll say for index, we're going to start off at 2, right? Because I've already done 0 and 1. Index is less than numbers.length. Index plus plus. We're going to assign numbers at the index equal to the numbers at the index minus 1 plus the numbers at the index minus 2. Right? Set the current index to what is previous and previous. Right? Now I could do the same printing here again in this numbers list. We'll get out our Fibonacci numbers. 1, 1, 2, 3, 5, 8, 13, 21, 35, something. 21, yeah. Oh, 34, 55. Right, so we get them back out. Again, so sure, that's kind of fun. So oftentimes we're going to loop when we have arrays to get a bunch of values out or do something with all those values. So loops are a lot of fun with our arrays. Again, this is a read-only loop. Now, once I have an array, we can also do other fun stuff with it here. So we can write methods that accept arrays as arguments. Right? So I'm going to write a method here, public, and let's return an integer for find largest value given an integer array. We'll call values. Again, whatever you want to call it here, perfectly fine. Give it a name here. As long as it's an integer array, you can hand it here. It could be size 1,000. It could be size 1. Right? We don't care inside the method here. So to find the largest number, just pause on arrays for a second here and tell me, if I just start naming numbers out to you, how do you know which one is the largest? If I just start shouting numbers.
I compare the ones we just shouted out with the previous.
Which previous ones?
So let's say you spit out 1 and 5. You think 5 is larger than 1.
Okay, and then I say
5 is the new larger.
Then I say 20.
So 5 is larger than both, or 20 is larger than both 5 and 1.
20 is larger, and then I say 7.
And that's not larger than 20, so it's not the new largest.
So you're tracking the largest value you've seen so far.
Yeah.
Right? Not all the previous, just the largest one. Okay? So we can say the largest value must be the first one until we know otherwise, right? Is that fair to say? Sure. So we'll say my largest value is values at index 0. The first number is the largest until we know otherwise. Then I can loop through, right? I can say for int number or int value in values, if the value is greater than the largest value, then my largest value is now the value. Right? When we're done, we can return the largest value. Right? Start with the first one until we find one bigger. Look at all the numbers. If you find one that's bigger, it's your new biggest, new largest. When we're done, we can return that largest value. Right? So we can do that. We could say the largest value you entered is, and throw in here, find largest value. Nope, 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 nope. Goodness. Those type ahead suggestions are awful. Find largest. Oh, I'm missing the static. That's why. Public static int. Now it'll show here. Find largest value given the user's numbers. Right? So any numbers they enter, we can go find the largest. We could find the smallest, right? We could find the average. We can do all sorts of fun arithmetic, fun comparisons with it for any size array. We could even, now the other fun part too, we could even ask them here. So instead of saying new int of 5 here, let's make our scanner up here first. We'll say, how many numbers do you want to enter? And we'll get an int for, I don't know, number of numbers, number of values. How about that? Integer.parseInt, given the keyboard.next line. And then when I size my array, I can size it size of number of values. It doesn't have to be a hard-coded number, unlike terrible languages like C++. C++ is awful. Java lets you do this. Most languages let you do this. C++ just sucks. Not that I'm, sure, a little biased, I guess, but I can say, okay, I don't know, you tell me. I want to store 20 numbers? Sure, and I'll store 20 numbers. And we're looping through, given the length here, we're always going to ask for every number they ask for. If they only want to enter 1, we'll enter 1. Now, 0, -1, those other sorts of things will probably screw things up. But again, we can probably assume we could do some sort of validation loop that it's greater than 0 if we wanted to, or even handle this if they don't enter a number. The other good things we could do that we've learned, we're just skipping for now. Right? Not that those are bad things, but we trust you can do that. All right, so how many numbers do we want to enter? 6. All right, what numbers are we going to enter? 2. Oh, I hit 12. I'll do 2. Sorry. 24. 5. How about -20? And one more. 17. Our largest value is 24. Does that check out? 24 is the largest we entered. Look at that. We can find the largest number in a dynamically sized list of numbers, right? Which is pretty cool, right? And this way now, before we really had no way of doing this. If I said, hey, how many numbers you want to enter? And I wanted to track all of them. We had no way of storing some dynamic number of numbers, right? Because I guess we could have done like number 1, number 2, number 3, number 4, number 5, and hopefully gotten more than they asked for. Right? But that would have been some terrible if logic, right? Like if their number is less than this, ask for all these problems. Like that'd be awful. So this is actually a new tool in the toolkit. This is where like methods didn't really let us do more things. They just let us be more efficient, let us put names to things. An array actually gives us new functionality, right? Brand new stuff we weren't able to do before with arrays. Again, this read-only loop, right? This is shorthand. You'll see this a lot. Let's see. We get out values. We get them out by index. Yeah. Okay, this one's interesting. So when you pass the values list here, right? This is a read-only loop. We can't change it. If I did want to change it here, though, right, I could say values at index, I don't know, let's just say 2 equals, just put a real big number in here, just to mess with it. So I'm going to print it out after we find the largest number. Because you gave me your array here, I can change the value stored within the array. In the read-only loop, again, we're not changing anything, but after the fact, I can go and change it here. Let's give this a run. So let's enter 5 numbers, 1, 2, 3, 4, 5. 5 is the largest, and then all of a sudden there's a giant number in here. We are able to change the value in the array, right, using this array notation. So if you have someone's array, you can change the values inside of it. What you can't do is I can't say values equals new int array size 20. I don't know, let's just do size 1 here. And then values at 0 is equal to a big number. Right, we'll fix this one up first here. Right? If I try and change the value of the array and assign it to a new array, remember what happens in memory is currently this numbers is pointed at this location. When you say equals a new something, it creates a new array in memory, say like x72fa, and says, hey, numbers, you don't point here anymore, you point here. So the array that we had here, called users numbers, still points where it used to. This array values that we passed, the values argument, values variable, points in a new location. We didn't change the user's number that was passed. Remember, like when you pass a string, strings are immutable. If you try and change the value or assign it somewhere else, you said, okay, now you point here inside the method. When we come back outside the method, this variable still points to where it used to. So you can change things inside the array because you're changing the value at the memory address. If you try and make a brand new array, you said inside the method, you point to a different place. The original variable still points to where it used to. So you can't wholesale change it into a new array here. Right, we'll say 5, 1, 2, 3, 4, and 5, right? We can't just go change it to say, okay, you're just a new thing here now. So you can't reassign it, but you can change the contents of an array. Does that make sense? So this won't change the place the array points outside the method. If that makes sense, saying where it points, like where this variable is looking to its memory address, it doesn't change any of that. Right? Another cool way you can create arrays if you know the contents ahead of time. So again, this only works occasionally here, but I can say, hey, I want an int array for, I don't know, first bunch of numbers equals, and then I can skip all that crazy notation, and I can say with a set of curly braces, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here, this is called the Array Initializer. So it's shorthand to say, hey, the first thing is 1, the second thing is 2, 3, you know, on and on. If you know what the values are and initialize it, it's the same thing as doing first bunch of numbers, index of 0 equals 1, on and on and on. Right? It saves you the time of doing all this here. Oh my goodness, those did not go down a line. Right, let me make this a little shorter actually, because that was tedious. So we'll go 5 of them. 0, 1, 2, 3, and 4. 5, 4, 3, 2. So it does the same thing as above. Right, so if you know what the values are, you can just hand it to the array and say, oh, by the way, here's your values. You don't even need the new int array notation. You just say, here's a bunch of values, rather than one at a time, you know, one line at a time, giving them values. So it's just another shortcut if you know the values. You can't do this with some sort of loop like, hey, enter the number. That's no good. You could give it variables here. I could say, hey, this was the, you know, number of values. So if I've got 5 different variables, I could hand it 5 different variables here. Again, it's kind of still of limited use though, right? So generally, if you're asking the user for values, we'll do it in some sort of loop. If you know what the values are, we can initialize them this way. Right? We couldn't do that with Fibonacci if we're doing the calculations here. Right? This was Fibonacci. Fibonacci, I think it's spelled like that. Are there 2 B's? I don't. Let me see. No, one B. Fibonacci. There we go. So we got the array initializer. We've got passing it as an argument. You can return an array as an argument if you want. So if you want to write a method, public static int array, we'll call it like add to my array, given an int array for values. Now, if you're going to return an integer array, we can change what's here and return the value as the array, and then we can assign it. So we could say, I don't know, for, what do we want to do? So we'll have an int array called new values. Oh, no, we can just change values, right? We can say value equals new int array of size, well, it's size of values.length. right? Take its current length, make a new array of that size. Then we can go through values. So we'll say for int index 0, index is less than values.length, values plus plus. And we can go change values then. Values at index here. Why is it unhappy with that line? Oh, value index, sorry, index plus plus. There we go. Values at index, let's say, I don't know, plus equals 10. We'll just add 10 to it. Then we can return the values list. So this makes a new array in memory. So it doesn't change the original values, but it makes a new array, right, of the same size. No, well, this isn't actually going to add to anything, right, because we made a copy. That's no good here. So we really need an int array, like new values here. We go change new values to be the values array at index plus 10. Right, if I want to get out the old value, sorry, get the old value, add 10 to it, add it to the new array. Oh, I said stop the call. Sorry, it should be on quiet. So this will take the old value, add 10, assign it to the new array, and we can return the new values when we're done. So if we wanted to, then we could keep both arrays in memory. So I could have my first bunch of numbers, and I could have a new int array of added to numbers. It would be the result of public static int add to my array the first bunch of numbers. Now, I'm kind of tired of typing this all the time, right? This is a little bit tedious, so I'm going to write another method, public static void print array, given integer array values, for number in values, print the number. So I can just call print array then, right, given my first bunch of numbers, and I can call print array given my added to numbers. So we should get 1, 2, 3, 4, 5, and then 11, 12, 13, 14, 15 when we're done, right? Because the first one shouldn't change, right? Because we didn't change any of the values. We made it a new array, took the values, added 10, but we didn't change them in place. So depending on what you want to do with your array, you could change it in place, or you could return a new array. In our case, this one gives you a new array back, so we're not changing the original. Just depends on what you're trying to accomplish. You can do either way. Enter one number, oh, we broke it. An array index out of bounds exception. Index 2 was out of bounds for length 1. I made this array size 1, and in our code we said, oh hey, let's change the value at index 2. If there is no index 2, your program crashes, and crashes hard with this array index out of bounds exception. You're going to hate these because these happen often when we're using arrays if we're not being careful. So if you try and access an index that doesn't exist, it just crashes hard on you. Right, so we'll get these all the time if you access an invalid index. So this means we did something wrong. So if we entered 3 numbers, then we'll have an index 2. Okay, so we get 1, 2, 3, 4, 5, and then 11, 12, 13, 14, 15. So we're able to create a new array that was added to the original without changing the original. So this one does not change the original here, purely because we made it not. We could have just said, hey, values at index plus equal 10 to change the original. But in this case, we wanted to return a new array. Again, just a choice, right? Well, we could have done either. So where this one actually changed the value in the array, this one did not. Okay, I think we're okay for arrays for now. Why don't we call that a day? We'll talk about array lists when we come back. Then after the midterm, we'll finish up array lists, and then we'll talk about file I/O and our last individual project for the term. Again, so starting 10 a.m. Wednesday, the midterm will be open. You'll have until 11/3 at 10 a.m. to hit submit. Okay, because I'd like to go over the answers on 11/3. We can go from there. That sound good? All right, any other thoughts, questions, or concerns? Anything from you folks online? Looking good. All right, everybody, you take care. I will see you then in a week and a half, right? Unless you tell me you want me to come watch you, I won't plan on showing up until 11/3. So have a good Halloween. Have a good rest of October. I'll see you in November. Take care.